Welcome back, and now we will see what is data frame in Pandas and how do you create a data frame. Basically, a data frame is a two-dimensional, size-mutable, heterogeneous tabular data structure with labeled rows and columns. Can be thought of a dictionary-like container to store Python series objects. And Python objects have attributes and methods like this. It will have attribute like columns, list the column names. And similarly, we have different attributes like axis. It will list the row, labels and column names. And n-dimensional, it will show number of dimensions in the data. And size, it is just like NumPy. It will show total number of elements. And shape will return a tuple representing the dimensionality, and values NumPy representation of data. It back convert to the NumPy from data frame to NumPy. And D types list the type of column. And we have some methods like headn, tailn, and we have a method like describe, max, min, mean, median, standard deviation, sample, and drop n. All these methods we will use in Pandas data frame. And there are some other functions also available. I'm just giving you some small number of functions. Okay. So first of all, we will create a data frame and then we will apply different functions or attributes over the data frame. So you can see here I have created a data frame from series. Like I have a series Alice, Bob and Charis, and I'm putting this series into a dictionary value and key is a name. Similarly, I'm creating another key is and the value of this is a series. So basically, it is a collection of series objects. I can run this block and you can see the output of D, and here we have 3 values in the name, so 3 rows, and 3 values in the age, so 3 rows in age, and the column names are corresponding name and age, and you can see here the indexing is 0, 1, 2. Now if you want to add one more column, so you can add one more column just like a dictionary. D of height, this would be the column name, equals to pd.series. We are providing the different values inside the series. So you can see now height is the new column added to the data frame. Name is height. Okay. This is the manual way to create a data frame. The most important uses of the data frame is to read data from different files. So here we are taking a file, salaries.csv file, and we are going to read through the pandas, and then we will do the different operations over the data inside the series.csv file. You can download this file from our website. You can scroll down here and you can see how to read CSV files. Download file, click here. And after downloading, you can see the data of the salaries.csv file. This file contains 6 columns. One is the rank, discipline, PhD, service, sex, and salary. Basically, I can say this file have salary of professors, professor, associate professor, or assistant professor. Then it have their service and their PhD and their discipline and their sex and their salary. So we have certain records, we have certain data of salaries of different professors in a file. Now we just want to analyze, we just want to extract some details from this file. Like I just want to extract the female professor who are getting the maximum salary. So I can do this type of calculation using the Pandas data frame. I think now question comes to your mind is, ma'am, we can do this type of question through the SQL queries also. But the difference between the SQL and Pandas is, for the SQL we need to create a table and then we need to put the data inside the table and then we need to write the queries. Here we don't need to put the data in any database. We can directly read the file and we can directly write the commands. Okay. So now I'm just reading this file, salaries.csv file. You can download this file and you can give here the complete path of the salaries.csv file. Otherwise, you can upload in your current folder by clicking over here. I have already uploaded, so I don't need to upload this file salaries.csv. Now I have read this file using read_csv function. I need to check what is the data inside this file, or my function is reading file correctly or not. So I can display the first few records using the head function. df.head and 10 I have written here, and you can see the top 10 records, all the columns of the top 10 records. So we can display the first 10 records, and if I'll ask you display the first 5 records, then what you will write? df.head 5. Similarly, I can give you the exercise like this: display first 20 records. So you can write df.head 20 and display the last 5 records. For that we need to write 5 or 7 records. We need to write the tell function, df.tell, and then we need to pass the number of lines. You can see the output here. So we are getting the last 7 lines. Now we will see the different attributes of this Pandas data frame. First, we are checking the type of df. You can see here the type of df is data frame, right? And check the type of a column. Like you just want to access a particular column. How to access a particular column from df? If you know the column heading, then you can write like this: df, and then inside the single quotes you need to write the column header. So df.salary, it will give you the one column. And if you want to check the data inside this column, then you can write df_salary.dtype. It contains the value integer 64. And if you want to check the data type for all the columns, then we can write like this: df.dtypes. And you can see the output here. Rank is object, discipline is object, PSD int 64, service int 64, sex is object, salary is int 64. Basically, objects means we have some string values. And now we can see the list of all the column names. Here we are checking the data type of all the columns. Now I just want to check the column names. So I can write like this: df.columns. You can see the name of the column. And similarly, I can check the row labels and the column labels. So you can write here df.access. Access will give you all the indexes for the row label and column indexes. So here index, rank, discipline, PSD, service, sex and salary. Data type is object. And for the rows we have range index, start from 0, stop till 78, and step is 1. So you can see we have 78 rows in our data set, and we have these 6 columns. Okay. Similarly, we can see the another attributes like number of dimension. You just want to check the number of dimension of the data. You know it is a 2-dimensional data. The number of dimensions, we can check the number of dimension in the data. You can see we have written here df.enddim. It is a 2-dimension data. So that's why it's giving the output 2. And total number of elements in the data frame we can check by df.size. And number of rows and columns we can check by using the shape attribute, df.shape. So total 78 rows we have and 6 columns we have. And then we have one important function that is called the describe. It will give you the basic statistics for the numerical columns. So you can write this, and you can see here the output. Like we have 3 numerical columns: PSD, service and salary. All remaining are the string. So basically for these 3 columns we will get the different statistics like count, mean, standard deviation, minimum, 25%, 50%, 75% and maximum. And we can calculate the mean for all numerical columns, df.mean. So you can see the mean for all 3 columns. So like this we can create a data frame, and then we can apply the different functions and attributes over a data frame.